The true power of BGP routing protocol lies in the fact how we can manipulate certain BGP attributes in prefixes in order to affect how the traffic is leaving our autonomous system, and to some extent how the traffic is sent back into our system. To do that, obviously, we need to know what the attributes are, how they are categorized, and how they can be influenced to accomplish our goals, and how the router selects the best path based on those attributes. What is the order of operations? So I'll be explaining those attributes one by one as we go along, but the route selection process is a document that I would definitely recommend reading. So if you go to website and try to find Cisco BGP route selection, and probably the first one, the first one here in the list would be the Cisco document, how the Cisco router selects the best path. While reading this document, we're going to discover that certain paths can be ignored, and there are circumstances when they are going to be ignored. One of them I already mentioned, for example, paths for which the next hop value, the next hop address, is inaccessible in the routing table. We cannot use it, install it, or re-advertise anywhere else. So there are some circumstances where the router is going to ignore the path for a given prefix. What follows is also the best path algorithm. So the router checks them one by one from the top until it finds the best path. If the best path is found, the remaining attributes or testing remaining attributes is ignored. So we start off, for example, if the path towards a certain destination comes from two different autonomous systems, let's say, and one value weight is higher than the other, the value with the highest weight wins. If weight for the same prefix from two autonomous systems or more is the same, the next attribute that is going to be tested is the local preference. If the local preference value is the same, again, highest wins. Then it goes to point number 3, it prefers the paths locally originated via network or aggregate BGP subcommands. If that's still the same, it goes to checking the length of a path, which is for the shortest. So for example, if I need to reach a certain prefix and I have one path with 2 hops, 2 autonomous systems to cross, and the other is with 4 autonomous systems to cross, the 2 autonomous systems is going to be better, the one that is the shortest path towards the destination. So you're catching the drift here. It goes one by one until it finds the best path. And I'm going to do that, actually use those attributes to manipulate traffic in the subsequent labs until we kind of get the idea how we can influence traffic going out or coming in to our autonomous systems.